In this video, we're going to learn how to synthesize ketones from nitriles. So remember, a nitrile is the functional group CN. There is a triple bond between the carbon and the nitrogen, and a lone pair on the nitrogen. Now, this can actually be reacted with a Grignard reagent, which is what we're seeing in this top line here. You're going to have your electrons from the Grignard attacking the carbon of the nitrile, and that pushes some of these pi electrons onto nitrogen, which gives us this up here. You can also picture nitrogen as having two lone pairs and a negative charge, and then a positive charge on the magnesium, if that kind of helps you see the formation of that better. And then you follow it up with aqueous acid, and you end up with your ketone. The same thing can be done with alkyl lithiates. You're going to have your alkyl group attacking your carbon of your nitrile, electrons getting pushed onto the nitrogen. This compound actually shows you the negative charge on nitrogen and the positive on lithium, because this would be ionic rather than the covalent thing that we see with Grignards. And then follow it up with aqueous acid workup, and you get a ketone. So the cool thing about this is that predicting the product is actually very simple. You just have to remember that the carbon that's in the nitrile will get turned into a carbonyl, and you're going to replace that triple bond to nitrogen with the R group of your Grignard. So if you can picture that, you can come up with your final product. I think the main mistake that students tend to make is they forget about the carbon of the nitrile, and then they end up putting the carbonyl on the first carbon of the alkyl chain from whatever was attached to the nitrile. So just make sure that you end up with the same number of carbons. That can be solved pretty easily just by doing some carbon accounting. So let's do some practice problems. Go ahead and pause and try to solve these on your own. So, just like in the examples that we saw on the previous slide, you have your alkyl lithiate. The electrons here in this bond are going to attack the carbon on the nitrile. So you want to keep track of that particular carbon. So we know that our ketone is going to have at least these atoms. This is our carbonyl carbon. We know this is going to get turned into a carbonyl, and then we're going to have 1, 2, 3, 4 carbons from the alkyl lithiate. 1, 2, 3, 4. So this is our product. Now we can do the same thing with the other one, because this is a very, very similar idea. All that's different here is that the aromatic group is part of the organometallic reagent rather than part of the nitrile, but the process is still the same. So it might be helpful to you to draw out the nitrile first and draw out the nitrile carbon, which of course you're welcome to not draw out, and then add on your R group from the Grignard. You can also draw it without actually drawing in the letter C, which is preferable. But if drawing in the letter C helps you, then go ahead and do that while you're practicing. So this brings us to another practice problem, and this is actually a practice synthesis. We have 2 of them that we're going to work through. Go ahead and take a second and pause the video and work on this for a couple minutes. You can probably do it, you just got to push yourself a little bit. So let's analyze our product and work backwards so we can figure out what we need to do to our starting material. Remember that one of the important things in synthesis is to remember that starting from the end and working backwards can often be much easier, because look at this. This is a primary alkyl halide. You can probably think of a million things that you can do with a primary alkyl halide, but you only know a handful of ways to synthesize a ketone. And since this is at the end of the nitrile to ketone video, you probably recognize that you might need to have a nitrile somewhere. So keeping that in mind, this is the carbon that is in the benzylic position, and our carbonyl is 1 carbon away. So that's one problem that we have to address. And then if we want to imagine this coming from a nitrile, we can doodle out our nitrile. And then we would need a 2 carbon Grignard. So let's go ahead and draw this out like a synthesis problem. If I had my nitrile, I could get to my final product by first reacting with an ethyl Grignard or ethyl lithiate and following it up with an aqueous acid workup. Doing that would get me my ketone, and that would be great. Is there a way to go from our alkyl halide to our nitrile? Notice here's our benzylic carbon. Here's our benzylic carbon. Have we ever seen a nitrile displace a bromine before? Hopefully you remember this from OChem 1, but this is actually a really simple situation. We just have to throw in some sodium cyanide, and this would be an easy SN2 reaction. So this synthesis that looked so complicated because you somehow had to have another carbon in there and you added on these carbons, you have your carbonyl carbon, but we only have this one benzylic one over here. It seems a whole lot more complicated than it actually was. And honestly, that's true for most synthesis problems. Now for this synthesis, you're going to have to reach back a little further to last chapter. Notice our final product is not a ketone, so this has nothing to do with nitriles and ketones. Instead, we have to figure out how to get an extra carbon onto benzene. So go ahead and pause and take a second to work this out. Okay, so this problem could be worked backwards or forwards. There are a couple different things that you could do here. One of the easier options would be, you know that you have to add this single carbon on here. So you know that your first step has to be a Friedel-Crafts alkylation. There's no other way that you're going to get that on there. You could honestly add on any amount of carbons if you wanted to. I'm just going to use methyl chloride. And that would take me right to toluene. Now from here, the only thing that we know to do from toluene to create a carbonyl is to oxidize it to a carboxylic acid, to benzoic acid. But then, do we know a way to turn benzoic acid into benzaldehyde? Yes, we do. We learned 2 reagents this chapter that could do that easily. So we could react with diabal in hexane at -78°C, or you could do this with lithium tritert butoxy aluminum hydride, and then follow it up with water. And to get from toluene to benzoic acid, we need to use potassium permanganate, hydroxide, heat, and follow it up with an aqueous acid workup to protonate our carboxylate product. Now, some of you might be wondering, could I have just done a Friedel-Crafts acylation using this compound? The answer is no. You cannot do that. It will not work. The hydrogen here is not going to be able to stabilize the resulting acylium ion that would form. So no, that is not an option.